Okay, this is assignment 4. Welcome to assignment 4. In this, we got more of the same of what we're doing with assignment 3. The addition here is from the LA 2911. These are different model routers, okay, and 1941s. The main difference is that there's a fiber link here. Okay, so what does that mean? That means on the 2911 here, okay, let me zoom in. That means you are going to take something like this, which should be the HWIC 1 gig SFP. So you take this module and you populate it into slot 0. Here, I'll just take one and demonstrate it so that you can drop it in here. Okay, can't do it while it's powered on, so be sure to turn your router off. Okay, so cool. Now you have your network module. You need a one of these things, the GLC long haul SMD. So you need to populate that. So yeah, we'll just go ahead and populate them all. That's fine. Okay. That means, okay, you turn that on. Make sure on your 2911 or your 1941, make sure that you have slot 0 with the same module and the same SFP there, or the SMD, what they're calling it. So that looks like it's here. See, 2 pieces there. Okay, so that means to connect that up, you're going to be using a fiber cable. Okay, so when you go to your connections here, it's this connection, it's fiber. You're going to be going to gig 000 over to gig 000. Okay, probably want to label that too. Okay, now the difference of the 1941s and the 2941s is that when you're running the iOS here, let me just bring up one interface. Okay, first of all, they're gig interfaces. They're not FAST-E. Okay, so we'll just do, let's see, if it's gig 00, it might be going that way. I'm just going to give it a dummy IP address. You don't have to do this. Okay, so gig 00, I'm guessing it's probably going out that way, or else it would have already showed up over here. Okay, gig 01. Okay, this is what I want to show you. You don't have to do this. You notice that the 1900, 2900, when you do show IP route, you're going to have a new entry here called local, right? This is the one that you're all used to, the connected route. But what does L mean? L means this is the host IP that's configured locally. So 222/24 is connected to gig01. It's directly connected. That's your network. The IP that's specifically configured on gig01 is 2222. 2222, and it is part of the 2220/24 network. Okay, so you see how that's rolling up there? Okay. So that means here, since we worked on getting a basic template here, why don't we get it going for LA 1941? Okay, we're going to paste that in. This is LA 1941 _1. Okay, so this is gig01 down on this side. Gig01, this description is linked to LA servers. 172.14.11.1. Okay. Okay, 14.11.1. That's over on this side. Okay, here's the other recommendation here for this subnet here. Last IP goes to the host. Last IP, then next to the last IP goes to the switches. Okay, so 254, that goes to your server. 253 goes to your switch. And you remember how we calculated out last host, right, from yesterday, right? It's all ones except for the 0 there. Next to the last, just take away 1 from that. Okay, cool. So this other side here is gig00. See gig00 right there, 172.14.212. This is going to be .1, this is going to be .2. So notice there's another network behind there. So 212 is the transit network to get to 12. Okay, this is our link to LA 1941 2 IP address 212.1. Okay, and no shut that. Okay, now let's get the other router in LA going. Okay, so right now, paste in that. It's LA 1941 2. Okay, so we're working with this router here. It's got one side going to 212, one side going to 12. Okay. IP address 212.2. So we're going to no shut that, and hopefully it comes up. CIS041, that's our link to LA users. And we're going to no shut that. LA 2911. Paste that in. 2911. Okay. Show IP interface brief gives you an idea of all interfaces that you have available. So the 2911s are going to give you 3 Ethernet interfaces by default there. So you got 0, 1, and 2. I believe I created this for 0, 1, and 2, right? And then gig 000 is our fiber link that leads upwards. So interface gig 000 link to LA. That's fine. 172.14.211.1. Okay, we are going to no shut that. And I do believe, if I'm not mistaken, I don't think we got the gig 00 set up over here. Yep, haven't set that up yet, so let's go ahead and do that. Okay, so that gig 00 is our link to the core. To 11.2. And we are going to no shut that. And our link turns up green. So we should be able to ping to 11.1. Okay, good. Let's keep going. Okay, gig 00, this is a link to SD. .1. We're going to no shut that. Gig 01, our link to NY. 172.14. 231.1. Okay, and gig 02 is down here. Link to SF. Okay, we're going to no shut that. Okay. Now to configure all of the spoke routers. Okay. Config T, paste that in, 1941. So gig 00, this should be our link to core. And that's this network right here, 221, 221.2. Let's no shut that. Hopefully it comes up. Thank goodness. Okay, the other side, gig01. Link to SD users. Okay, it's 21.1. Okay, good enough. We should be able to ping 221.1. Okay, good. On to the next. Okay, config T, paste that in. NY 1941. Gig00. It's our link to core. 231.2. And we're going to no shut that. So that was up here. Gig01. Link to NY users. Okay. So notice we're still in interface config mode. So let's do a do, and we're going to do a privilege exec command. 231.1. Just going to make sure we could ping there. Good. So let us now get SF router going. Okay. Gig00, that's our link to core. IP address 241.2. Okay, so we no shut that. Gig01, link to SF users. 41.1. And we'll no shut. Okay, cool. Okay, now let's take stock of every single route here. So we know it's going to start with IP route 172.14 dot something. So what do we got? We got 11, 212, 12, 211, 221, 21, 231, 31, and 241 and 41. So we got 11.0. Okay, we got 12. We also have the 212 there too. We also have 211. 211's over here. Okay, what else we got? Like, I don't know, maybe we could do like pairs here. That'll probably help keep us straight there. So we got 21 down there. And 221. Okay, we got 31. Two 31. Okay, 41. And 241. Okay, so from LA 1941, from this perspective right here, it's already gonna know about 11 and 12. Well, it's gonna know about 11. It's gonna know about 211. It's gonna know about 212. Right, but it's not going to know directly about 12. So this is the transit network right here. Okay, so that one doesn't matter, that one doesn't matter. To 12, to get to here, to get to this next hop, or to get right here, its next hop IP, it's going to be 172.14.212.2 to get to the 12 network right here. Okay. So it's not going to know, it's not going to care about the directly connected 212. Okay, so to get to the 21 in the 221 network, to get to any of these, this next top IP is going to be 172.14.211. Okay. So it's going to want to go towards 172.14.211.1. Okay, so to get to that one, yep, not touched. 212, it's already directly connected, don't need that. But for everything else, 172.14.211.1. All right. So let's drop this in here. Okay, I don't feel like typing Cisco twice. So I just hit save there and do config T. And then paste in all the routes. Okay, nice and efficient there. Okay, so this was the LA 1941 1 routes. Okay, and notice I'm commenting it out there too. Okay, so LA 1941 2 routes. Okay, reset. Okay, now to get to, from this perspective, for the LA 1941 2, its next hop IP to get everywhere else, it's going to be 172.14.212.1. That's the next hop. Okay, it's 212. Okay, 212.1. Okay, so this router here, it's not concerned with 212. We don't need a route because it's already connected. And we don't need one for 12 because it's already connected. Right, so it does need for 14, for 211, 14.11, 14.211, and then all the others. So from this perspective, it's next hop, it's just forwarding it out to this router. Okay, so let's come in here. Paste that all in. Okay, so when we do show IP route, yeah, we see directly connected right here, and we can filter for directly connected. Show IP route connected. That shows we got 12 and 212 right here. We can also show IP route for static that way. Okay. So cool. At least from this perspective right here, we should be able to ping at least the far side of this router, 11.1. We should. Cross your fingers. Okay. All right. Okay, let's go to our hub router right here. So this is actually the hardest part. Okay, this is the LA 2911, right? Okay, we'll reset here. Reset. Okay, the directly connected network is 211, so we're not going to be concerned with 211. 221. Okay, 221 is directly connected. 231 is directly connected, and 241 is directly connected. Okay, now to get to the 11 network, our next top IP, 211.2. Okay, and to get to the 212 network, 212 network, 211.2. And to get to the 12 network that's over here, 211.2. Okay, so you see that there? The next one here, to get to the rest of these networks, the rest of these 3 networks, okay, to get to the 21 network, it's gonna be 221.2. Okay, to get to the 31 network, 231.2. And to get to the 241 network, or to get to the 41 network, it's 241.2. Okay, so kind of following that logic there? Okay, I didn't bother changing the ones that are already commented out. So yes, technically we can just delete those, but we still need them for the other routers. So commenting out is just fine for us to keep moving forward. Because it kind of keeps that same process in place. Okay, so we paste in those. Right? So to get to 11 and 12, we're going to go out to 11.2. To get to the 21 network, it's 221.1 or 221.2. 231.2 for network 31 and 241.2 to get to network 41 out here. Okay, good. Okay, this is going to be the SD. Okay, SD 1941 routes. Okay, reset. Okay, find out the directly connected, which is 21 and 221. Directly connected. Okay, to get to everything else here, 221.1 to get to everywhere else. So that's SD here. Paste that in. So we should be able to ping 11.1, and if we were to trace to 172.14, 12.1. See, follows it all the way down. Cool. Okay, NY. Let's take this. Yeah, let's copy this one. Okay, this should be the NY, right? That's the 31 and 231, if I'm not mistaken. Okay. So its next hop IP for everything else, it's 231.1. So it's 221. Replace that with 231.1. Okay, replaced all. Okay, so New York, gonna paste this in. And hopefully from this New York router, we can ping that far side, the 172.14.21.1. Okay, there's all of our static routes there. Okay, so cool. Last one is SF, right? SF is 41. So reset here. We're not concerned about that one and not concerned about that one. So the next top IP for everything, 241.1. Yeah. Okay, so from here, we should be able to ping 31.1, 21.1, and even 11.1. So 11.1, if we're to trace that out, yep, two hops away. Okay, cool. Cool. So open recent. Okay, open up our syscode template because, yep, got to get our switches done. So I'll just blast through this really quick. $29.60 interface VLAN 1, 21.253, no shut, and IP default gateway 21.1. So that means we should be able to ping 11.1 at least. Okay. NY. IP address. Ah, I see. Okay, then we'll no shut. 31.1. Okay, this one's 41.253. Default gateway 41.1. Yep, and make sure you can ping like 11.1 or something. Okay. And we got the other switch here. LA 29.61. IP address 253. No shut. Default gateway 11.1. Okay, I also want to show you simulation mode. So after we get this switch going here, I want to show you how to troubleshoot just in case there's a break in the path or something like that. Okay, no shut. 12.1. 31.1. Okay, so we'll try this. I'll show you the simulation mode here. Okay, simulation mode. We're going to do show none, edit filters for ICMP and ARP. Okay, hit enter there. And look, hey, we got an ARP packet going out. So this is going to be processed outbound. Outbound is going to go out layer 2. And notice here too that it's going to be going out as a broadcast. Okay? Broadcast, all ones. Okay, so the ARP process constructs a request to the target IP address because it's not there in the ARP table yet. Device encapsulates the protocol data unit into an Ethernet frame. Switch uses the active VLAN interface. So we just configured interface VLAN 1. That's the active IP. And this is a broadcast frame. So the switch is going to send out the frame to all ports in the same VLAN except the receiving port. Okay, so this is what it looks like. So preamble, that's just our synchronization bits. Destination address, this is layer 2. This is Ethernet 2, layer 2. Destination address is to all ones there. Source address, this is E671. Okay, this is an ARP. Source MAC is this, E671. Source IP, it came from 12.253. Target MAC, we don't know it yet. This is what ARP is for. But we know the IP. We know the IP, which is 12.1. Okay, so here's what's going to happen. See, ARP goes out here to this router IP. It's processed inbound. Okay, frame's destination MAC address matches the receiving port's MAC address. Okay, the frame is an ARP frame. ARP must process it. This is an ARP frame request. ARP's request target IP matches the receiving port's IP address, and ARP processes and updates the ARP table with the received information. So comes out here, gets processed for outbound. Okay, E671, remember that was on the router here. Or actually that was the switch host. 7743. 7743 is where? So if we come out to this, okay, that was 7743, right? Show IP ARP. Okay, this is everything that I ARP for. Okay, so let's keep going back. So this means right here that to get to any remote network, it's going to be going out the front door. So that MAC address is going to be of the front door. I'll show you exactly what I mean when we do our Wireshark lab. Okay. So just know that if you're crossing to another network, no matter what IP it is, what remote IP, it's going to be the MAC address of your front door. That's why your default gateway is so important. And that's what ARP is for here too. Okay, so ICMP is going to craft. So now it has the MAC address. Has the MAC address of the front door. Okay, so now ICMP is going to build source IP, destination IP, along with source MAC and destination MAC. Okay, this is an ICMP echo request. An echo request is going to be an ICMP type 8. ICMP type 8 for echo request. Echo reply is going to be ICMP type 0. Okay, just keep those in mind. Okay, we see the packet going forward, going out to here, going out to the next route here. Okay, and notice here too, device looks up destination IP address in the routing table. That's your big hint here. If it finds an entry, it's going to say this: the routing table finds a routing entry to the destination IP address. If it doesn't, then the packet's going to die. You're going to see a red X right there, and you're going to see, hey, there's no route to the destination. So what does that mean? That means fix it. Okay. So there the packet goes up, right? Yep, switch to real time and 2962. Yeah, so we have our success rate here. It's 80% because this first portion right here, yeah, the router had, or the switch had to go out and ARP first. So that's why we lost our first ping packet. Okay, cool. So let's go ahead and let's see. Yeah, let's get our server configured for DNS. Make sure it's on, and that we have a record for www.abc.com 172.14.11.254. Okay, 11.254. That's what we got there. Okay, 12.254. Let's see if we got our host here, if we can ping abc.com. And there we go. Okay. Likewise, make sure your host is configured over here. abc.com. Got a reply good. abc.com. Looks like we're good there. And SF. Okay, at the same time, make sure you can telnet to some of your other routers. Yep, looks like we can. Yep, then to maybe a switch. Yep. Okay, and then just make sure that all your segments can ping each other. So you start at one place, start pinging everybody else. start in another place, ping everywhere else. Okay. All right, folks, so that is how to get 100% on assignment 4. Okay. Good luck.